Kicking us off there. I'm Henk van Rijn from Hull Marine Consulting. I also work on the Insight Program Director team with Dickon, Georgina and Mario. I'm going to walk us through session 1 today, where we've got some great presentations lined up. Building on the objectives that Colin introduced, in and around that, it's been a very interesting couple of decades in terms of marine technology and innovation. So this session, we thought we'd kick off with a lot of the techie stuff. And you're going to hear from Dan Jones from the National Oceanography Centre, who has been working on the ATSEA project. Dan's going to be talking about autonomous exploration of the environment at the Northwest Hutton decommissioning site and an awful lot of AUV work there. We're going to hear from John Halpin and Joseph Marlowe, both from Scottish Association of Marine Science, both working on the North Sea 3D project. And John's going to be talking to us about the analysis of imagery data, some of the lessons they've learned through that process, and I understand there's quite a bit of AI that's now involved in that project. And Joe is going to be talking about creating 3D visual reality environments to promote understanding of structures in the marine environment, and a plug for some of the VR work and demonstration outside the room. So please give that a go. I think Joe will be talking about that. And finally, bringing us in at the very end of the session will be Josh Lawrence from Heriot-Watt. Josh is working on the fish spams project, and he'll be talking about the sampling challenges around marine artificial structures and how those challenges can generate innovation with low risk, low cost, low carbon marine autonomous systems. So without further ado, we're going to move over to Dan, who's giving us an online presentation from Southampton. So I'll cue Dan. There's Dan there. Welcome, Dan.
Hello, everyone. Thanks, Hank. It's great to be able to speak to you all today, and apologies for being online only. It would have been good to see you all in person, but I'm going to be presenting on our approach of using autonomous vehicles to characterise bits of the environment, and using Northwest Hutton as a good example of where we're going to go and the sort of things that we can find out. So as Hank says, this is part of the ATSEA project, one of the Insight projects, and it's a work of quite a large team across NOC and the University of Southampton, including an extensive use of the UK Marine Autonomous and Robotic Systems fleet team as well. So after Colin's excellent talk, I barely need to give an introduction to the North Sea, but there's a few things to point out that are really relevant from my point of view. One is there's a lot of structures. There's also a very complex environment. There's lots of things going on. There's heavy fishing activity. There's busy shipping lanes. And there's actually high currents and a lot of environmental factors as well. All of these make challenges in trying to use autonomous systems in this sort of environment. We've also got some other challenges as well. We've got trying to understand what the role of structures are. It's complicated. There's positive and negative effects. We need, as Colin said, decisions to be made that are really quite important, requiring robust scientific evidence. And we need a lot of new data gathered through regular environmental survey and monitoring to understand how these changes relate to the changes in the natural environment that are being caused by temperature change, by acidification, all those other things. To do that, we need to be regularly visiting sites in the North Sea and elsewhere. And we have been using the latest generation of autonomous systems to try and address the question of whether these autonomous systems can address some of these challenges, and whether the use of systems that are deployed from shore to go to these relatively remote sites can improve the way that we do marine environmental monitoring. So, for example, we think there might be reduced cost. That could translate to increasing the number of missions, so increasing the frequency of sampling. It might require smaller teams. It will increase safety because you don't have to have people out there, and it can have a drastically lower carbon footprint. But the key question is, it's great if they can go there and collect data, but they need to be able to provide the environmental evidence that's needed in the places that are needed. We're using Northwest Hutton as an example. It's a relatively standard structure in the North Sea that has been decommissioned. It's about 150 metres depth, it's quite old. It's been decommissioned already, and we're left with footings on the seafloor. So this was our target site for a number of reasons. One is we had quite good data for the site, and the other is that we were able to visit it and collect additional data as part of the programme. So we tried it. We went out to Shetland. We launched this autonomous vehicle, auto sub-long range, or boating at boat face, according to the popular press. And we launched it from Shetland, and we carried out 2 missions, one to the north to Northwest Hutton, and one to the south to Braemar Potmarks and the Miller decommissioning site. These missions were both successful. It took about just over 20 days, covering over 1,000 kilometres, and used a very small amount of energy, about the equivalent energy of a couple of litres of diesel fuel, although this is a battery-powered vehicle. And during that mission, we were able to collect thousands of colour images, millions of black and white pictures with laser lines, and as well as a whole range of additional data, ADCP, CTD, and some sensor data on the hydrocarbons. We didn't use, but we could have used an eDNA sensor. At the time of the deployment, we were not able to use that, but we could have now, so that would be a potential for future activities as well. And we wanted to hit some key environmental monitoring targets. We wanted to look at the role of the structures. Unfortunately, we couldn't actually directly go too close to the structures because of the way that the vehicle was controlled, but we were able to go to areas of cuttings piles quite close, within a few hundred metres of the structure. We were able to explore the water column above and around the structure and the seafloor in the vicinity. And we wanted to look at the range of parameters that are generally used, to look at biological, physical, chemical impacts, and looking at other related issues as well, like debris and hazards. So we characterised the seafloor using the autonomous vehicle, as well as using some standard mapping from the Scotia the year before to provide some sort of comparison for the site. So the acoustic mapping from the ship is broad scale, and it can be platform independent. Actually, it doesn't really matter what platform you use for the mapping. Although fine scale mapping, particularly in deeper waters, is easier with AUVs, and you can carry out change detection as a result. The seabed imagery through an AUV is a good platform for seabed imagery, but as I said before, we can't get close to the structure. We can't do things like sediment grain size through that imagery approach, which means that it's difficult to compare to some of the previous data that have been collected from the site. But you can see we were able to collect a centimetre resolution bathymetry data with the AUV, and we were able to collect some high-resolution photographs. You can see this octagonal structure on the seafloor. At the bottom, it's photographed, and the top is the microbathymetry, clearly showing the structure at very high resolution. We were also able to use the ADCP on the autonomous vehicle to collect profiles of water current speed and direction over the structure. And this is the backscatter from the ADCP, and you can see the structure quite clearly. We can also characterise the current speed around the structure as we go over it, and we can see there's evidence here of a sort of a downstream reduced current and a change in current direction as well associated with the structure. We collected a relatively small data set on this mission, but we could have collected a lot in quite a straightforward way. We were also able to use a suite of 3 chemical sensors on the vehicle to look at methane, PAH, and some other parameters whilst we were carrying out the mission. There was no particularly exciting information from Northwest Hutton. We weren't expecting there to be, but we did visit the Braemar Potmarks, which are an area of active methane seepage, and we were able to detect a methane peak as we went over an active potmark, suggesting that the technology could detect relatively large leakages, although it may not be appropriate for looking at the smallest things that could happen. We were also able to characterise the biological environment. Using a standard survey, you can see the sort of, at the top, the high-resolution pictures of sea anemones and urchins on the seafloor, so we could characterise those, see how they changed in response to the disturbance. The AUV was able to collect a similar data set, not quite as high resolution, but over a much wider area. And you can see the fish very clearly in the imagery, and you can even see them in the bathymetry data. So sort of conclusion on that is that the AUV is possible to collect quite a lot of this kind of information, but not all of the stuff, particularly the information that's typically collected, for example, with the sediment macrofauna. The other thing of this AUV survey is we were able to detect quite a few other things as well. We could see a whole range of debris in the images, and we were able to georeference those precisely. We could see potential hazards for seabed operations and characterise the impacts. You can just about see on the picture to the right that the colours you're seeing are sort of the actual imagery mosaicked over that wide area. And you can see fairly clearly that there's a dark seabed area around Northwest Hutton, which we assume is related to the oil impacts. So it's quite interesting that even at that resolution, you can start to see some of the changes. So to try and summarise, can the autonomous survey meet the monitoring requirements? We felt that the pre-decommissioning assessment of cuttings piles can be done, or at least partially done. Going to structures is always going to be a challenge because of the dangers of operating a vehicle like this around the structure. And I think we'll have some excellent talks later about work with structures that we weren't able to do with an autonomous survey. Once the structure's removed, it's a bit easier. We can carry out debris surveys. We can characterise the environment in some ways, but not as many as we would perhaps like. And if a structure is remaining in place, we can potentially monitor some infrastructure like pipelines that are relatively low relief, and we can carry out ongoing environmental monitoring. So I think the conclusions are that we can do effective remote sensing, and we have done at Northwest Hutton for a range of parameters listed there. And we were able to do that with much lower cost energy and emissions than we would have been able to do in the ship. But we can't do some of the really common survey operations that are typical for the North Sea, looking at the sediments themselves and particularly the informal biology. We can't get close to the infrastructure, but we can get to the edge of the cuttings piles, and we need to characterise exactly whether we can see the same patterns in the remote sense data as we can in the sort of standard data that we're collecting. But it does have many opportunities as well beyond decommissioning monitoring. There's looking at marine protected area monitoring, blue carbon assessment. And so ultimately we feel the AUV offers a complementary approach where you can combine a autonomous survey with a shipboard survey, targeting the shipboard survey to a much smaller scope and get a lot more information that's informed by the autonomous operations. So with that, I'll finish. Thank you very much.